Today, we're going back in time to explore a chapter of our planet's history that most people barely remember. A period when Earth was struggling to stand up again after the worst mass extinction ever recorded. My name is Arthinox, and this is Cloaked Mysteries. An age of reconstruction, chaos, drastic change, and the rise of creatures that would shape the entire future of life. Welcome to the Triassic, the silent cradle of the dinosaurs, the natural laboratory that prepared the planet for the most legendary domination it has ever seen. Get ready, what you're about to see is not just science. It's the true story of the greatest biological resurrection our world has ever witnessed. The Triassic begins in a desolate setting. Earth had just gone through the largest extinction in its history, wiping out almost all marine life and a huge portion of land-dwelling species. Ecosystems were devastated, silent, and full of empty niches. Very few species had survived, and all of them were fighting for space, food, and adaptation. The world was ready to be rebuilt from scratch. The planet, freshly emerged from chaos, looked unrecognizable. The climate was unpredictable, the soils were poor, and ecological interactions were fragile. That instability created harsh, brutal conditions for any form of life. But it also created opportunities, and in Earth's history, big opportunities always produce big rulers. In this unstable environment, the few survivors spread across Pangaea. Animals that once played supporting roles suddenly became the main characters, simply because they had survived the disaster. Small herbivorous synapsids, for example, became incredibly abundant, taking on the role of the base of the food chain at the beginning of the period. Even so, as resilient as they were, these animals were not destined to rule forever. Every group that rose to prominence carried the weight of a world that was competitive, ever-changing, and relentless. Nature was rearranging its pieces, and every evolutionary advantage was precious. It was a silent race against extinction itself. The Triassic, therefore, doesn't begin with stability. It begins with vulnerability. But in biology, vulnerability is not weakness, it's fuel for transformation. And it was this transformation that paved the way for the rise of creatures that would change everything, including the destiny of the planet. In this way, post-extinction Earth became a vast natural laboratory. A stage where new forms of life would be tested, shaped, and selected under extreme pressure. It was the opening chapter of one of the greatest evolutionary revolutions in history. During the Triassic, all the continents were fused into a single gigantic landmass, Pangaea. It stretched from pole to pole, shaping winds, ocean currents, and extreme climate patterns. Living beings faced enormous distances without oceans to soften the climate. That made the interior of the supercontinent brutal and arid. At the heart of this immensity, colossal deserts stretched for thousands of kilometers. Giant dunes, similar to the largest in today's Sahara, crossed regions where almost nothing survived. Rain was rare and unpredictable, and only a few highly resistant organisms managed to thrive in these places. Along the edges of Pangaea, however, the story was different. Near the oceans, conifer forests grew in abundance, creating corridors of life. These coastal environments were refuges of biodiversity, supporting rich and complex ecosystems that sharply contrasted with the harsh, dry interior. Despite its appearance of solidity, Pangaea was far from stable. Fractures were beginning to open in its crust, signaling that one day it would break apart into smaller continents. The planet was about to change its own geography, and that fragmentation would have a deep impact on the evolution of life. The supercontinent even influenced the amount of oxygen in the atmosphere. Concentrations were lower than they are today, making survival harder and limiting the size of many species. That oxygen-poor atmosphere made the Triassic even more challenging, increasing the selective pressure on every form of life. Pangaea was a stage of extreme challenges but also fertile ground for evolution. Under constant pressure, new lineages emerged, reinvented themselves, and competed. The scene was set for the birth of the future giants of Earth. While the continental surface dealt with heat and dryness, the oceans were putting on a completely different show. Panthalassa, the massive ocean that surrounded all of Pangaea, housed a vibrant and deadly universe. In its waters, marine reptiles rose as elite predators, shaping entire ecosystems. Among the giants of the seas were the ichthyosaurs, creatures with dolphin-like bodies and huge eyes adapted for hunting in deep water. Some of them reached extraordinary sizes, comparable to a modern bus, cutting through the waves with impressive speed. In shallower waters, other creatures ruled. Nothosaurs, with their long necks and sharp jaws, dominated coastal environments. Agile and efficient, they were opportunistic hunters, capturing fish, mollusks, and any prey that ventured too close to the surface. Primitive reefs were also beginning to take shape, creating natural shelters for countless species of fish and invertebrates. These reef systems were less complex than today's, but they already played a fundamental role in supporting marine biodiversity. Curiously, there were no polar ice caps during the Triassic. The global climate was warm enough to prevent ice from building up at the poles, leaving the seas free of frozen frontiers. This helped drive powerful ocean currents that spread life across vast distances. In the ocean, life recovered faster than on land. And while land species struggled to rise again, the sea was already pulsing with giant predators that would define marine food webs for millions of years. Within this rebuilding world, one group began to stand out: the archosaurs. They were robust, adaptable, and versatile reptiles that quickly took over dominant positions in terrestrial ecosystems. Their evolutionary success was so great that it would shape the future of life on Earth. Among the largest archosaurs of the Triassic were the erythrosuchids. These predators, reaching up to 5 meters in length, had powerful jaws and muscular bodies. They sat at the very top of the food chain, hunting herbivores with brutal efficiency. Another equally important group was the Parariquias, agile, slender reptiles moving toward a more upright posture. About a meter long, they were fast and alert, probably hunting insects and small vertebrates in quick, precise ambushes. The evolution of these animals was crucial for the rise of the dinosaurs. Many archosaurs already showed traits that would later become essential in big sauropods and theropods, such as limbs positioned directly under the body, more efficient lungs, and adaptations to endure extreme heat. Archosaur biodiversity grew as the climate and habitats became more complex. Species specialized, invaded new ecological niches, and expanded their survival strategies. Every new adaptation brought a significant competitive advantage. The Triassic, therefore, was the stage where archosaurs established themselves as the new rulers of the land. And it was from them that the most famous lineage in evolutionary history would begin its ascent: the dinosaurs. The first dinosaurs appeared quietly. Small, light, and fast, they slipped under the radar of the giant predators of the Triassic. Yet every detail of their anatomy hid advantages that would change the evolutionary future of the planet. These early dinosaurs, like Eoraptor and Herosaurus, were agile carnivores that hunted insects, small reptiles, and primitive mammals. They had upright posture, more efficient lungs, and muscles adapted for fast, sustained running. Over time, new groups began to emerge. Herbivores like the plateosaurs, bigger and more robust, entered the scene, feeding on tall plants and hardy vegetation adapted to the arid climate. They formed large herds, helping protect smaller individuals and making their search for food more efficient. Contrary to what many people imagine, Triassic dinosaurs weren't giants. They were just at the beginning of their evolutionary journey. But even as relatively small animals, they already showed the versatility that would make them dominant in the Jurassic and Cretaceous periods. One of the dinosaurs' main advantages was their active physiology. They regulated body temperature more efficiently, moved with greater agility, and recovered more quickly from injuries. That made them highly competitive even when facing older and larger predators. In the quiet background of the Triassic, the dinosaurs were planting the seeds of their future golden age. The world had no idea, but it was standing before the future rulers of Earth. While the dinosaurs were taking their first evolutionary steps, another group was also beginning a long journey: the primitive mammals. Small, discreet, and nocturnal, they lived in the shadows of the great reptiles, surviving through a strategy of staying unnoticed. These early mammals descended from ancient synapsids. They had furry bodies, eyes adapted to the darkness, and nighttime habits that protected them from extreme heat and daytime predators. They hunted insects and lived in burrows and cracks in the ground. One of the best-known representatives of this group is Morganucodon. About the size of a mouse, it was agile, clever, and incredibly well adapted to survival. Despite its modest size, it already carried traits that would later define modern mammals. Many of these animals still laid eggs, much like today's platypus. That reveals the deep evolutionary transition they were going through, part reptile, part mammal, a living bridge between two great eras of life. Even though they were fragile, these small survivors spread across Pangaea, finding niches where large predators couldn't reach. Their quiet, low-profile lifestyle would be crucial for enduring millions of years of ecological upheaval. These primitive mammals are the direct ancestors of all modern mammals, including us. In the Triassic, they weren't the stars of the show. But they were silently preparing the stage for the appearance of creatures that would one day dominate the planet in a very different way. The Triassic climate was predominantly hot and dry. The sheer size of Pangaea kept oceanic moisture from reaching its interior, creating gigantic deserts and arid conditions that deeply shaped the evolution of animals and plants. Along the coasts, however, the picture was more balanced. Forests of conifers, cycads, and ferns spread out, forming rich environments that supported herbivorous dinosaurs, insects, and countless small vertebrates. This contrast gave rise to varied and complex ecosystems. The dominant plants of the period were resistant to heat and drought. Conifers formed vast forests that acted as ecological sanctuaries, while ferns covered the forest floor with dense, moist vegetation. These extreme conditions favored animals capable of surviving in hostile environments. Many reptiles had efficient metabolisms for conserving water, while small mammals evolved nocturnal behavior to escape the scorching daytime temperatures. The Triassic also saw seasonal climate shifts. In some regions, winters could be cold, and there might even be occasional snow, proving that the period wasn't purely tropical, as many imagine. This mix of extreme aridity and humid coastal zones created a mosaic of habitats where species needed to be flexible, fast, and innovative. And it was in this diverse, challenging world that dinosaurs and archosaurs found room to thrive. The Triassic came to an end with yet another mass extinction. Not as devastating as the Permian event, but still powerful enough to reshape the planet once more. The exact causes are still debated, but massive volcanic eruptions and abrupt climate changes are strong candidates. These eruptions released enormous amounts of CO, altering the atmosphere and raising global temperatures. Species unable to cope with these changes vanished quickly, opening up new ecological spaces. This extinction event wiped out many of the dinosaurs' competitors. Groups that had previously dominated were reduced or completely eliminated, leaving the dinos free to occupy nearly every available niche. With that, the Jurassic began on a renewed planet, and with dinosaurs finally ready to step into their role as Earth's supreme rulers for the next 135 million years. Once again, life proved its resilience. Every crisis forged new leaders. And the evolutionary history of Earth continued its cycle of destruction and rebirth. The Triassic, therefore, wasn't just another era. It was a rebirth. The moment when Earth stood up after a catastrophe and gave rise to some of the most incredible creatures that have ever existed. The Triassic is proof that life always finds a way. In the midst of chaos, extreme heat, and devastation, small and unlikely creatures emerged that would change everything: dinosaurs, mammals, and marine predators that would build the foundations of the world we know today. It's a reminder that every ending holds a beginning, and that sometimes the greatest stories on this planet start in silence, long before anyone notices their magnitude. If this journey through the Triassic sparked your curiosity, let me know in the comments. Which creature from this era would you like to see featured in a full episode here on the channel? And don't forget to subscribe to Cloaked Mysteries, turn on the notifications, and join me on our next journey into the unknown.